Wow. Hello, welcome to my channel where we take practical, simple steps in solving very seemingly difficult problems. So, like I've emphasized in my previous classes, I've talked about the issue of drawing. Drawing is very crucial in solving problems in physics. Once you draw, you are halfway through in solving the problem given to you. So having drawn, because of time, we can see that it's used to convert ice at minus 10 degrees Celsius. We should be conversant with the state of water, liquid, solid, gas, you understand, at what temperature. So the knowledge of that helps us in having this diagram here. So if the 1000 liter is used to convert ice at minus 10 degrees Celsius, this is the ice. Ice is also, water is ice, it's in a solid state at 0 degrees Celsius. Water is also liquid at 0 degrees Celsius. At 100 degrees Celsius, water is liquid. At 100 degrees Celsius, water has become also gas, which is vapor, or in other words, steam. So having drawn this, and we are told to calculate how long will it convert 0.5 kg of ice? How long will it convert it? So, knowing fully well that heat loss is equal to heat gain. Heat loss is equal to heat gain. Law of conservation of matter. Heat loss is equal to heat gained. Who is losing and who is gaining? From this place, you can see it is the 1000 watts heater that is losing heat. Is losing heat to the ice. So we can see, and heat loss, energy, is power times time. So PT, that's the formula for energy. Energy is power. Let's have this here. Energy is power times time in seconds. So having that knowledge, that will help us here. So this is power times time to convert. So we are looking for time. So here, this whole thing here, P times T is equal to, this is the one that is gaining the whole energy here. So we can see here there is change in temperature. Because there is change in temperature, we have our MC theta ice. Here, there is no change in temperature. We call it hidden. That's that word latent. Latent means hidden heat. Heat that is absorbed that does not reflect on the value of the temperature. Heat is absorbed, but it does not reflect, does not cause any form of change in the temperature visible to the eye. So we can see 0 degrees Celsius, 0 degrees. So we call here MLI. Here we can see there's a change in temperature, 0 degrees Celsius to 100. So here this is MC theta of water. Here we can see there is no visible change in temperature. This is MLT. So this guides us in knowing when to use each of these parameters. So power times time is equal to MC theta ice plus MLI plus MC theta water, well, yes, plus ML steam. So with this, we can now solve. We know that our power time will now be equal to all of this. All over power. So now go ahead. Mass. Define your parameters. You know what mass is. You are given that mass is equal to 0.5 kg. And that thing you must also be very careful. is the issue of the units. You must make sure that the unit that you are given is the same. If they are not the same, here is kg, here is kg, you must be very, very careful. If you are giving gram and you are saying that the unit specific heat capacity is in terms of kg, you must convert your gram to kg. So having done that, you can now go ahead to solve this problem. You see that 0.5 times C, specific heat, which is 2001, times ice. What is the this is final temperature minus initial temperature. This is final temperature minus initial temperature. You can see in this case, this is your final and this is the initial. 0 degrees Celsius minus 10 degrees Celsius to give you 10 degrees Celsius plus your 0.5 times the specific heat, specific latent heat of ice. Yes, which is what? 3.36 times 10 raised to power 5 plus 0.5 times 4002 times, what is the change in temperature? Here we can see 0 minus 0. That's why here this is 100 minus 0 degrees Celsius, giving us 100 plus here you can see this is 100 minus 10, so it goes away. We are just left with 0.5 times 2.26 times 10 raised to power 6 all over 1000 watts. So when you are done, your answer should be in seconds. So do that. When you are done, give me the answers in the comment section. I hope to see you in my next class. Bye.